Welcome to your next quest. Okay, so you finished your last assignment, and the project manager says, "That's great. Excellent thinking when it came to taking the level into account. Now I have another task for you. I'd like you to bind to that onXP change delegate we created in the player state, and I'd like you to bind to it on the widget controller for the overlay. Why? Because our overlay is going to have an XP bar, so it needs to know when our XP changes. Now, as a bonus, see if you could figure out what that percent will be for the XP bar. Now, this is deceptively a little bit more difficult than you might think, as the way that we calculate the percent depends on what level we are. So, see if you can figure that out. And as a hint, does the overlay widget controller need level up info? Because level up info contains those level up requirements for XP for each level. So, see if that's something you're going to need. And if you do, where should level up info go? We created the data asset blueprint, but we never set that on any of our classes, right? So try to think about where a good spot for that level up info should go, and try to keep in mind that we may need that level up info in our widget controller, both on clients and server. And just remember that the game mode doesn't exist on the clients, it only exists on the server. So right away, I'm telling you it probably shouldn't go in the game mode. So give it a little bit of thought, see if you could figure that out, and if you're up for a bonus challenge, give that a try. But either way, I'd like you to bind to onXP changed in the overlay widget controller. So pause the video and conquer this quest now. Now we're going to need to bind to our onXP change delegate in our widget controller. Now it's possible that we may decide to bind to onLevel changed as well, so that's something to keep in mind. But when we bind to onXP change, we're going to want to figure out what that XP bar percent is going to be, so we'll keep that in mind as well. Well, the first thing we should do is go to our widget controller class. That's going to be in UI widget controller, and it's our overlay widget controller. Here is where we're going to want to bind to the delegate, right? So I would like to make a callback function to bind because it's going to be a little bit more complicated than just passing through that value up to widgets. We're going to be performing some calculations, right? So I'm going to make a function in the protected section, and this is going to be for when our XP changes. We're going to bind it to the delegate on the player state called onXPChange delegate, which can only have functions bound to it that can receive an int32. So here in overlay widget controller, we're going to make a function. It's going to be void, and I'm going to call this onXPChanged, which will take an int32 called new XP, and we'll go ahead and generate the definition for it. And before we figure out what to do in this function, we're going to bind it. So we need to go up to our bind callbacks to dependencies, where we're binding to all of our callbacks, and we have a few bound to the ability system component. We have some bound to the attribute set, but we don't have anything bound to the player state. So we're going to have to get our player state, aren't we? So up here, as we're getting our Aura attribute set, I'd like to cast to the Aura player state as well. So I'm going to go ahead and create a const pointer to it, and it's going to be of type Aura player state. And I'm going to go ahead and include the header file. So Alt-Enter and Writer will do that for me, adding the include for it. It's in player/player state, and I'm going to call this Aura player state. Now I'm going to use cast checked for this. By the way, in a package build, this compiles as a static cast, so you have that bit of optimization there too. Now this will be an Aura player state, and we're going to cast our player state variable that all widget controllers have. Now we know that we have the Aura player state, and we can bind callbacks to the Aura player state. I'm going to actually move this Aura player state local variable up to the first line, and the first thing we'll do is bind to the player state callbacks, and then the attribute set will be after that. So after getting the Aura player state, we can take Aura player state, and we can access that public on XP changed delegate, and we can bind to it. We're going to use add U object. And with the user object being this, and the function being the address of U overlay widget controller on XP changed. And of course, we're going to get red squiggles here because now we're actually changing something on the player state, so it can't be a const pointer anymore if we're going to want to bind callbacks to delegates. Okay, so now we have a callback bound to onXP change delegate. So we'll know in the widget controller when our XP has changed. Now we need to broadcast something up to our progress bar in Blueprint. But the thing is, we can't just broadcast the total amount of XP. We need to find out what the percentage of that bar should be. And that's going to involve the use of our level up info. So what class should have the level up info? Well, I think the player state is probably a good class to keep that level up info, as it is the class that has the level stored on it. And also, the player state is replicated, so if we access the player state in our widget controller on the client, we can get level up info from there. So I think a great place for it is here on Aura player state, right here in the public section. So I'm going to go ahead and declare a public variable. It's going to be a T object pointer. Now its type will be U level up info, and we can forward declare that. We don't have to include level up info up here. We can just say class U level up info here, and we can create this variable called level up info. And we can make it a U property with edit defaults only, so we can set it in our player state blueprint. So we'll remember to do that. And in our widget controller, we can access that when determining how much our percent bar should show. And that's going to be all in on XP changed. And once we figure out that percent, we can broadcast something up to our widgets. Now, what are we going to broadcast? Well, we're going to broadcast a float for the percent of our XP bar. And if we want to broadcast a float, we have an on attribute change signature we can use. It's not an attribute. Our percentage for the XP bar technically isn't a gameplay attribute, but we can still use this same delegate. If the name bothered us, we could create a new delegate with a different name capable of broadcasting a float, but that's a little bit silly. I think we could just use this delegate signature and create a new delegate. In fact, I'm going to give it a U property, so I can take one of our other attribute changed signatures and copy it. And down here at the bottom of it, in the public section, I'm going to paste, but change the name, and this will be on XP percent changed. And we'll tack on delegate at the end there. And this will be gas/XP for the category. So now we have a delegate to broadcast. Now we just need to figure out what that percent should be and broadcast that in onXP changed. Now here in onXP changed, we're going to want the level up info, and we know that that exists on the player state. So we can access the player state with a cast checked. We'll go ahead and copy that line and paste it there. Don't worry about using cast checked each time our XP changes. As I mentioned, this turns into a static cast in builds, so this is not something to worry about performance-wise. So in onXP changed, what exactly are we going to do here? Well, we need to get our level up info. So I'm just going to say U level up info. We'll get a pointer to that. We'll call this level up info. And we'll use our Aura player state and get that level up info public variable. And what we'll do with our level up info is we're going to perform lookups for data from it. So this can be a const pointer. And if we like, we can perform a check on that. We can say check level up info. And we can even use a check F if we want a descriptive message. When level up info is a null pointer, we can say unable to find level up info. Please fill out Aura player state blueprint. So we'll definitely know if we forgot that. we'll get a crash or an assertion in debug mode with that message. So how are we going to know what our percent bar should be when we know what our XP is? Well, level up info has a handy function that can tell us what level we should be for a given experience value. We can take our level up info and call that function. It's called find level for XP. It takes an int32. We can pass in new XP. Now we made level up info const, and find level for XP could be const. So one has to change. Either this function can be const, and then our pointer can be const, or the function can not be const. But if it's not const, then our pointer can't be const. Well, if it's just a lookup to find level for XP, it could easily be const. We can go into our public ability system data folder into level up info, and we can make find level for XP a const function. We'll have to do it in the header and the CPP file. And once we do that, then here in the widget controller, we can call this function no problem. So this gives us the level. It's an int32 returning function. So we can create an int32 called level, and now we know what our level is. Now that's important because we need to know how much XP to get from the beginning of one level to the end of that level. In other words, that delta XP requirement. And if we're going to be finding delta XP from one level to another, we should know what that max level is. So we should have a const int32 called max level. I said const, we'll make it const in a second. Max level equals, and we'll get our level up info and access that level up information and get the number of elements in it. So the number of elements in it should be the max level possible. So these both can be const ints. So we know our current level, we know the max level possible. We need to figure out that delta between the amount of XP when we first reached our current level to the amount of XP at the end of that level. In other words, its level requirement. So first I'm going to place a check here that says if level is less than or equal to max level. That way we're in range here. But I'm also going to have an and make sure level is greater than 0. Because a 0 level doesn't make sense either. Now the level requirement for our current level, that can be accessed from our level up information. So I'm going to make a const int32 called level requirement or level up requirement. And that's going to be our level up info, accessing level up information from it and indexing it at our current level. But that's a struct which contains the level up requirement, so we have to access that. Now I want to know the previous level requirement. In other words, the XP that we were at the very beginning of our current level, that's the level up requirement for the previous level. So I'm going to make a const int32 called previous level up requirement. And that's going to be level up info, accessing level up information, indexing it at level -1, the previous level, and then getting that level up requirement. So now we have both of those. Now we can see the difference between them, a delta. We can say const int32, delta level requirement, we'll call it. And that's simply going to be the current level requirement minus the previous one. And it's actually level up requirement minus previous level up requirement. The reason we need this delta is so that we know what to divide our current XP value by. Now, current XP, remember, is a cumulative total. What we need is how much more from the beginning of our current level we have. In other words, if we're level 2 and we had to reach 300 to reach level 2, and now we have 400, then to calculate the percent, and the level up requirement for level 2 is, say, 900, in other words, 600 more, then our percent would be 100 divided by 600. It would be our current XP minus last level's requirement. So we're going to say const int32 XP for this level equals, and it's going to be new XP, that's our current value, minus previous level up requirement. And finally, we can calculate the XP bar percent. And this is going to be a float because we're going to do a division. A const float, we're going to call this XP bar percent. And this will be our XP for this level divided by the delta level requirement. Now, we don't want to perform integer division. We want to perform float division. So we can static cast these to floats. Or we could have done an implicit cast and created floats for these variables. Either one, it doesn't really matter. We were working with integers up to this point, so this is the point at which we need them to be floats. So we can say static cast, and this is just a regular old C++ static cast to float. We're going to static cast both of these to floats. So we'll static cast this one, and we'll static cast this one. And now we have XP bar percent. We can broadcast. We can take our on XP changed, and actually our delegate is called on XP percent changed delegate. We'll broadcast this. This can broadcast a float. We're going to broadcast XP bar percent. All right, well, that was quite an experience. And if you did this all on your own, I'm pretty impressed because that was quite a problem to find a solution to. Pretty nice. And by the way, this could be a const function or a player state, could be a const variable. We can just make these const correct. On XP changed in the header file can be made const here. And with that, we now have our widget controller responding to XP changes. Now, it'd be great to just go into our XP bar in Blueprint and bind to this on XP percent change delegate. You can see that I just compiled while I was talking there. But we're never actually changing our XP. That's going to be something we have to do when we accomplish something like slay an enemy or whatever. So there's really nothing we can do at this point to test it unless we just change our XP on the player state willy-nilly. But that's okay. We'll test it soon enough. We're going to implement this in stages. For now, we have our callback. We even have this code to find out the XP bar percent. We'll see very soon if that's correct. And things are looking good. So excellent job with this quest, and we'll continue in the next video. I'll see you soon.